purpose of this presentation is to announce the formation of the Landfill Odor Standard Working Group, sponsored by IEEE Censors Council. The standard will be IEEE P2520.2.2. This picture illustrates the problem that we will address. Waste generates malodor complaints globally, yet there are no standards for instruments that measure those malodors. And this is what we want to develop in this working group. Odors are generated by the decomposition of waste by bacteria. And these bacteria decompose the organic waste and create a mixture of gases. The most abundant of these gases are greenhouse gases, namely methane and carbon dioxide. But additional gases are also emitted that have very strong odors. Examples are hydrogen sulfide, which has a rotten egg odor smell, many volatile organic compounds, and ammonia, which is sharp, pungent, and urinous. Some people say cat urine. Hydrogen sulfide and other components of these gases can remain in the atmosphere for a long time. For example, H2S remains in the atmosphere for about 18 hours and collects in poorly ventilated and low-lying areas downwind, which is responsible for some of the complaints. Where does this global waste, how much global waste is there? It's massive. According to the World Bank, about 2 billion tons of municipal solid waste is generated each year. If you look at the circle on the right, in the light blue, it says 44%. That is food and green waste. For example, just unused food or waste from trees and branches and even cut grass. If you look at the dark blue where it says 17%, that is paper and cardboard. So those two together, which are organic materials, are over 60% of the global waste. There are many other things that are in the waste: glass, metal, plastics, wood, rubber, and leather. And then the other category on this circle, where it says 14%, that can be things like electronics, construction materials, textiles, and other types of waste. So this waste goes into two types of areas. One is our open waste dumps, where there are no controls whatsoever. Things are just dumped into those sites. And the other is landfills. And these are more controlled and engineered sites. This is an example of a landfill design from the kind of standard book of Worrell and Vesland. And you can see on the right, there's a dark line where it shows a boundary between, at the bottom of the waste, and the groundwater. The purpose of this liner is to prevent the waste from getting into the groundwater. And it also is to prevent the leachate, the liquid portion that drops to the bottom of the waste, from getting into the groundwater as well. There's also a leachate collection system where you try to collect this water or leachate and treat it as well. There's a gas collection system. This is this kind of pipe that comes up, and what happens is it is typically flared or sometimes used for energy. And hydrogen sulfide can be burned in this as well, and you ultimately get sulfur dioxide, which unfortunately also does happen to have a smell. There's a daily cover that's put on the top of this as well. It can be soil or synthetic to reduce the odors. But overall, it will certainly reduce the odor, but odorous gases still migrate up through this waste because it's not 100% sealed, and it's not airtight, and you will get odors in the environment. What countries have the highest waste generation? Well, according to the World Bank, China, the United States, India, Brazil, Indonesia, and Russia. In this slide, I'd like you to look simply at the black and the gray. The black is waste that is put into open dumps, and the gray is what's put into landfills. You can see China, almost 70% is either in a landfill or a dump. In the US, 50%, more than 50% goes into landfills. India, almost 80% goes into dumps. In Brazil, almost over 90% is either in a dump or a landfill. Indonesia, 80% into dumps and landfills. And in Russia, it's almost all dumped. So a lot of malodors are coming off this waste in these different countries. How do odors travel? Very similarly to smoke. They can rise up in a plume and come down, and you don't necessarily know where it's going to come down. Why I want this slide in here is to understand that even a monitor at the edge of a landfill may not pick up the odor that is generated on that landfill if that plume rises up and does not hit any monitor at the end of the landfill. Why should we care? Well, first of all, looking at the odor anatomy, odorants come and they bind to little receptors at the top of the nose. This is a blow up of that area. And there are neurons that go directly into the emotional areas of the brain. So when you smell a malodor, you're going to have a reaction. Some of the reactions that are reported in the literature are anxiety and worry, stress due to the unpredictable nature of the odor, altered breathing patterns, headaches, nausea and loss of appetite, sleep disruption, dizziness and fatigue, and decreased quality of life. And this is not an unusual response from a person who is experiencing malodor. Now, to characterize malodor, which is what we're going to have to do in this standard, we're going to use the FIDO or FIDO framework for characterizing odor. F stands for frequency, how often does it occur? I for intensity, what's the strength? And this is typically done in what's called odor units, or how many times do you have to dilute it to get to threshold? The duration, how long is it? How offensive is it? That's the O. And the location, where is it perceived and where is it generated? So the purpose of our working group is to develop this standard for what are called instrumental odor monitoring systems, IOMS, or e-noses. And we have to look at what tools there are currently available to validate the effectiveness of these devices based on the FIDO framework. And I will describe these just briefly in the next slides. Odor diaries, olfactometry monitors, wind monitors, portable detectors, grab samples, and dispersion modeling. Here's an odor diary. Odor diaries can be related to IOMS data. They'll tell you start time and stop time, which will give you an idea of the duration. The location will be the L. The type of odor, because it's garbage, sewer, fecal, pungent, ranch, which will give you an idea about the offensiveness. The severity will give you an idea about the intensity. So odor diaries can be related to the IOMS devices. Olfactometers can give you an idea about the intensity. These are two that we use, nasal ranger and the centometer, and you can dilute the air with odorless air until the smell is barely detected. And so when you barely detect it, that's 1 odor unit. So if a sample is diluted 10 times to reach this detection threshold, this corresponds to 10 odor units. This doesn't necessarily have to be done in the field. You can take Tedlar bags and fill the air up and use them in the laboratory. This is one of our olfactometers in the laboratory. And you can smell it and dilute it and see how many times you have to dilute it to get rid of the odor. Another way of looking at duration is to use a continuous monitor that might look at one particular compound, for example, hydrogen sulfide. These are two that we've used. And these instruments convert hydrogen sulfide to sulfur dioxide using UV fluorescence. And they'll be continuously monitoring the hydrogen sulfide, which will give you some idea about at least one compound that is in the odor plume. This can also be done continuous monitoring with ammonia. And this is another instrument that we've used. Or you can also look at wind direction um, and decide how long that duration of that odor is, if it's blowing in that direction. There are also portable monitors that we've used. One is photoionization detector that measures all the VOCs, and they're portable hydrogen sulfide and dust monitors, and to see how those relate to the IOMS devices. Another possible way of relating to the the ENOS or IOMS devices is using grab samples with a SUMA canister, where you take the air sample and then you send it to the lab to look at what the compounds are in there. And this will be helpful in the following way. You can correlate the chemical compositions, let's say on a landfill or dump, with those in the community. You can see right here that these compounds are exactly those that are found in the down in the community itself, which will give you an idea that the odor in the community is related to the landfill. And what we want to do is to see, are there IOMS fingerprints at the landfill in the community that are similar? A final way, these are just some of the methods, is to use odor dispersion modeling. And in this way, you can take emission rates, which are generated by LandGEM, how much emissions would you expect from a landfill, or odor units or hydrogen sulfide, and measure them downwind. This is an example. I'm not sure this was a landfill, but you can see that if this is a space that's emitting odor, the dark portion says that there's 10 odor units here, and 5 here, and 3 here, and 1.5 here. And these models are done with programs called AirMod, CalPuff. They're helpful, but what they don't do is to tell you how odors linger, because I told you that hydrogen sulfide can stay around for 18 hours after it's emitted. So all of these are helpful in trying to validate our IOMS devices. So the standard will looking at training the IOMS device using these things that I just talked about, diaries and olfactometry and instrumental data, and to try to get fingerprints that characterize the odor, and to achieve real-time estimation of odor using the Phytol characteristics, and to provide or propose performance metrics that could be used by regulatory agencies, and to help develop these IOMS devices so they do comply with odor regulations. We would love for you to join our working group. The project was approved in May 2025 by the IEEE Sensors Council. We're looking now at baseline performance specifications under the leadership of Dr. James Covington. And our first working group for this landfill odor monitoring will be in January 2026, with monthly meetings after that. We would love for you to volunteer and to attend the first meeting. Just contact Dr. Nagel, and this is his address.
I'm not seeing any questions in the chat. But I think I am excited about the technology, and would love to hear more about the development of that in conference coming up in May. So maybe we can talk more about opportunities to talk about the working group and the standards that are being set and doing it. If they're, yeah, I think we're coming. I just turned off my live stream, so I'm not confused by what's going on the screen in terms of our discussion. Are there any questions from the panel here for Troy and Susan?
I think this is really a crucial area, because landfills, as I showed in the slide, are the main way of disposing of waste, which just keeps increasing and increasing. There is incineration in Europe, but very little in the United States or China or the Far East. And having standards are really important. I've recently been involved in 2 landfill cases where there have been geysers, odors just traveling throughout the community, and we have to have some way of documenting it other than people saying, "Oh, it was horrible."
Yeah.
So the idea of having electronic nose technology, I mean, I envision sensors placed around a landfill and on the landfill and downwind from the landfill. They could be there could be radio communication, and to be able to say, what is the frequency? What is the intensity? What is the duration? Right now, the best thing that I've found, and it's not foolproof in any way, is to use a continuous hydrogen sulfide monitor. But that always underestimates the problem because there'll be times where the hydrogen sulfide is not that high, but the odor is still terrible. So I think the hydrogen sulfide monitor can be helpful in terms of duration. It will give you an idea if the odor is in fact there, but it's not going to give you an idea of the entire intensity.
Yeah, the landfills are indeed a dynamic environment. They're not a static entity at all. The placement of waste, the management of waste, the movement of waste, the degradation of waste in the landfill is a very much an active process, and quantifying the emissions from that is challenging.